when I say the terminology, the nerve, when I say nerve, a group of fibers outside the central nervous system. So what we should not do is we should not say the nerve fibers passes from the right cerebral cortex to left cerebral cortex. The nerve cells passes from the brain to the spinal cord. We should not use this word nerve because the classical definition of a nerve itself is it is out of the central nervous system. Just for a knowledge sake, but interchangeably we are using this terminology. Not an issue. Next is the ganglion. What is meant by ganglion? You come across this name ganglion everywhere when you are studying. Ganglion means a collection of cell bodies. So when I say neuron, neuron has a cell body, axon and dendrites. So where are these cell bodies? They are always found in a collective manner. The nerve cells are in a collection. So if it is located outside the central nervous system, it is called as a ganglion. Okay, and if it is located inside the central nervous system, they are called as nucleus. Got it? So nucleus and ganglion. A classical example is the posterior root ganglion or the dorsal root ganglion, which is near to the spinal cord, is the one. And for the nucleus, you have a lot of examples. You have basal ganglia, nucleus. You have nucleus for the cranial nerves, and you have nucleus for the gracilis and cuneatus, the sensory relaying of the proprioception. So nucleus is the gathering of nerve cell bodies which are located in the central nervous system. Next is the gray matter and the white matter. Gray matter means there is a lot of cell bodies located. They looks gray in color because of the matrix substance within the nerve cells. And white matter looks very white. They carry only the nerve axons which do not have any cell bodies. They look white because of the myelin sheath, which is rich in protein, which gives a white color to the these things. So when I told you about the difference between the myelin sheath in the peripheral nervous system and the central nervous system, you can see the chaining of the oligodendrocytes, and oligodendrocyte produces myelin for multiple axons, whereas the Schwann cells produce only for one thing. And see the distance between the nodes of Ranviers of the peripheral nervous system and the central nervous system. You have nodes of Ranviers very widely away from each other. That means the saltatory conduction here of nerve impulses is going to be very fast, and there is going to be parallel processing of the information because the axons are connected parallelly. So any complex information can be easily progressed and processed through this particular type of nerve chaining, whereas here only monotonous information can be either it is inflammatory, excitatory or inhibitory. That is the only thing that is going to be transmitted through these nerves, and they are going to be much slower than the processing that happens in the central nervous system. Why? That is mainly because of the oligodendrocytes which are present.